Okay, for testing the ovens, on our first test day, we tested a sample of water to see how much the water heated up over the 25 minutes that it was out there. So the students had a thermometer, just a regular lab thermometer. They measured the temperature of water in just a little glass dish like this. And then they put the water inside the oven. They did not measure the temperature of the water while it was in the oven, just before and after to look at the change in temperature. But they did measure the temperature of the oven while the oven was sitting outside. So they got an initial temperature of the water, an initial temperature inside the oven, and then they took a piece of acrylic plastic and put the acrylic plastic over the top of the oven to keep air from escaping. Okay, now I'm going to talk about different modifications that students can make when they revise their ovens after doing the first test. Like I said, one common modification was for students to choose to duct tape the cracks in their boxes so that they wouldn't have air escaping out of the sides. So I wouldn't give the students any suggestions exactly about what to do, but would ask them questions. In this case, the question would be, how can you prevent losing heat by convection? And then they would come up with the idea of the duct tape. I would also ask them what they can do about losing heat by conduction, and they might lose heat by conduction on the bottoms of their boxes. So some students added some sort of like a tripod type thing, or not a tripod in this case, but had 4 stands, something so that it wasn't touching the ground so much. Other students added extra insulation to the bottom. And that was a common a way to solve a conduction problem. We also talked about how to improve the amount of solar radiation that got into the box. And one modification in this case, when we talked about the butterfly's wings, which are on the PowerPoint that's available online, and we talked about black and the texture of the wings. Some students crinkled the paper to try to make it blacker, make it so they could absorb more light. It doesn't necessarily help, but it's a way for them to think creatively about solving problems. Another way students got more solar radiation was to add flaps to the sides, and some added flaps to the front as well. But you might have to remind students that they don't want to make a shadow in their box. So adding more flaps was a way to get more solar radiation. And then we gave students the opportunity to do some extra credit projects, and they could design their own. So you can see that students can use any type of box. It doesn't need to be a pizza box. This is a shoe box, but it worked the same way. This is one example. Another example is a cereal box, and the cereal box opens up the same type of design. Students, if you don't have the acrylic plastic to put on top, when they do it at home, they can use saran wrap. Doesn't work quite as well, but it still works. We have this one. Students that make them at home for extra credit can spray paint the outside black. In this case, the student created an inside that had an ultra-reflective mirror. So some students added mirrors to try to get more solar radiation in. And then we have some interesting designs that may or may not have worked. This one is a coffee can with a funnel on the top and some plastic. And then we have one that turned out pretty neat, and this one was a funnel design as well. And it was kind of like a solar or a radar dish, I guess, a satellite dish. So large foil-shaped circular design. The last thing I'm going to talk about is the final testing of the oven. For the final day, we retested the temperature inside the oven over 25 minutes, but we let the students cook something in their ovens. Depending on the amount of time you have, you could do lots of different things for your ovens. If you have enough time, you can cook an egg and talk about proteins denaturing, which would be a nice nanotech tie. And if you don't have enough time for that, you can melt cheese on top of a tortilla or something like that, something simple. And if you have a lot of time, like you're at elementary school or you block schedule or something, where you have all day, you could do a cook-off where, depending on the actual designs of the students' ovens, they may or may not be able to cook, actual foods like rice or something like that. So you could do something that's more fun where they have a choice of what they want to cook. Okay, if you do a cook-off and you're at a high school level as opposed to having younger kids like me, one thing that might be fun for them to do, and it would incorporate more mathematics as well, is to take a recipe and, knowing the temperature inside their ovens, be able to modify the recipe to be adjusted for cooking a certain amount of time in their solar oven with the temperature that they reached testing it before. So doing a recipe modification would be good for older grades.